given the function y equals x squared minus 1, find the average rate of change of this function from x sub 1 equals negative 2 to x sub 2 equals 0. So to get us started, let's begin by recalling the formula for the average rate of change of a function. So we can recall that the average rate of change of a function, given a function y equals f of x, on a small interval of x values where x is greater than or equal to x sub 1 and less than or equal to x sub 2, is an adaptation of our slope formula in function notation. So given this formula, let's start by finding the corresponding y values for each of our given x values. So when x sub 1 is equal to negative 2, we can say that f of negative 2 is going to be equal to negative 2 squared minus 1. So minus 2 squared we know is 4, and 4 minus 1 leaves us with 3. So the first point on the graph we are considering is the ordered pair negative 2, positive 3. So we can say when x is negative 2, y is positive 3. And very similarly, we have when x is 0, substituting 0 into our function, we have 0 squared minus 1, or 0 minus 1, which leaves us with the corresponding output value, negative 1. And plotting this point on our graph, we have the second ordered pair at the vertex, 0, negative 1. And we know that the average rate of change of this function is going to be the slope of the secant line connecting these two ordered pairs. So we're now ready to substitute these values into our average rate of change function. So we can say that the average rate of change is f of 0 minus f of negative 2, all divided by 0 minus a negative 2. So plugging in our function values, we have negative 1 minus 3, all divided by, now notice in our denominator, we have a negative multiplied by a negative, so we know that becomes positive 2. So we have negative 4 all divided by positive 2 for a beautiful final answer of negative 2. So this is the average rate of change, or the slope of our secant line. And since our slope is negative, we know that this means our function is decreasing over this interval of x values.